Kia ora Year 12. This is video number 4 on partial fractions. This time we're going to look at a pattern type where we've got a quadratic factor in the denominator. So the example that we're going to start with is this one here. Suppose that we want to write this as the sum of partial fractions. So far so good, but the second factor in the denominator is x squared plus 3. So we can't do anything with the real numbers to factorise that. So what does that mean we've got to do? Well, let's try what we always do. Split it up into 2. Look at the factors in the denominator. And it doesn't look so bad, so why don't we try just whacking down A and B. Right, now let's think about what's going to go wrong. So pause the video here, try and do your cross multiplying and see what's going to happen. Okay, well hopefully what you saw was that we'd have coming in first, we're going to have 4x take away 1 equals a times x squared plus 3 plus b times x minus 2. So we have a problem because we've got this ax squared here. A is not equal to 0 and we've got nothing to get rid of that. But over here we want to end up with 4x minus 1. So we need something to offset this thing here. So the way we're going to do that is like this. We're going to have 4x minus 1. So when we split this time into our two factors, here we're still going to have a constant a here, but we're going to have a linear factor up here. Right, now how's that going to help us? Well, it will work like this. When we cross multiply, these two together are going to give me a second x squared coefficient, and that's going to offset this one here. Okay, so you'll get the idea as we get into this example. From this point on, once you've seen that pattern works, basically it's the same idea as with all the other ones. But it makes sense to use a mixture of substitution, which is what we've relied on a lot in videos 1, 2 and 3, and matching the coefficients, which is another name for when we go through with simultaneous equations. And it usually pays to use both of those methods. So again, pause the video and see if you can work through it on your own from here. I'm going to go through it pretty slowly on the next couple of slides. Okay, so what we've got here is the denominator is going to be 4x take away 1 is equal to a times x squared plus 3 plus bx plus c times x minus 2. And I'm going to do some substitution here to get one of those coefficients worked out. I'm going to do that first, but I'm going to leave a wee gap to come back and expand that out. So let's substitute in, as we always do. We look for values that are going to make one of these terms equal to 0. So x equals 2 will do that. On the left hand side I get 4 times 2 take away 1 is equal to a times 2 squared plus 3 plus my bx plus c times 0, right? 0 because it's 2 minus 2. So what does that give me? Well, I get 7 is equal to 7a, and that gives me a equals 1. So that's very nice. Now what can I do next? Well, I can't substitute a value of x in here to make that 0, right? There's no real value of x that will make this 0, so we can't do that. So we have to move on to equating terms. So to do that, I'm going to go back up here and expand out this side. So here we get ax squared plus 3a plus bx squared plus cx minus 2bx minus 2c. Very good practice for expanding easy quadratics. Next I'm going to collect up my like terms, and then I'm going to match coefficients. So this is actually pretty easy once you've got the hang of it. It's just working with like terms. So there's c minus 2bx, so let's just go back and tick off which ones we've used. Right, it's good to have some kind of system for this. And lastly, my constant term will be 3a take away 2c. So they're all done. And just make sure as you're going through a problem like this that you don't go too fast. Now, look what we've got back over here. We've got 4x take away 1. And we could write in there if we wanted to, 0x squared plus 4x take away 1. Now we're going to match the coefficients. So first we're going to match the x squared coefficient, and we get 0 is equal to a plus b. But we know what a is. A is 1. So 0 is equal to 1 plus b. So b is equal to negative 1. And next we're going to match, well, we can either match up the 4 here with this coefficient, or we can match the constant term, the negative 1, with 3a minus 2c. That's what I'm going to do, but you can choose whichever you want. So here we're going to have negative 1 is equal to 3a minus 2c. We know what a is, it's 1. A is equal to, negative 1 is equal to 3 minus 2c. Negative 4 is equal to negative 2c, which gives me c is equal to 2. So we're done. All I have to do now is to write the answer out nicely, okay, because we're asked to write that single fraction as the sum of partial fractions. So I'm going to do that on the next slide. So we've got 4x take away 1 over x minus 2 times x squared plus 3 is equal to 1 over x minus 2 plus, what was b? b was negative 1, so negative x plus 2 over x squared plus 3. And that's going to look nicer if we write it like this. 1 over x minus 2 plus 2 minus x over x squared plus 3. 4x minus 1. Once you've done a few of these, you'll get into a pattern of recognising that if we end up with a 1 here, you can start to see the cross multiplication happening. You're going to have a minus 1 or a minus x here to get that all to work out. Okay, so the more practice you do at these, obviously, the better. This video is long enough, so I'm just going to do that one example in this video. I'm going to do partial fractions 5 will be another one of this pattern type, and I'll put the ones for you to do in there. Thanks for watching.